Okay, dear students, so let us see this question. The horizontal component Vh and the vertical component Vv of the velocity of an object are shown on the graphs. Air resistance is negligible. It is given. Again, I'm pointing out this is very, very important for IB. So we have noted this thing down. Now, according to these graphs, it is evident that the horizontal velocity component is constant. It never changes. So this is giving a constant value. So it is same as whatever it was started with. So let us recall our projectile motion that we have studied. Like let us say this is the projectile motion, somewhat like this. Please pardon my drawing here. So now here, this is the velocity, this is going to be Vh and this is Vv. So let us first of all try to understand this thing. In all kind of horizontal motions, there is acceleration only and only on the vertical axis. There is no acceleration on horizontal level. So in horizontal level, the velocity will not change, it will be constant because there is no acceleration on horizontal. But on vertical, there is an acceleration which is acceleration due to gravity g. Fine. That is why the velocity which is vertical will be a variable. It will not be constant. But Vh is always constant. This horizontal velocity never changes. It is always constant. So this thing is perfectly correct for an oblique projectile. This is known as oblique projectile, but it is correct for the horizontal projectile also. What is horizontal projectile? This one. This is known as horizontal projectile, and that one is oblique projectile. Now, moreover, let us now consider this graph. The vertical velocity is increasing, but it is positive. It is not changing sign yet. It is decreasing, and then there is a time, there is a moment when the velocity becomes negative. It means the velocity changes the direction. Earlier it was moving up, or let us say it was moving down, and then it is going up. So that is not possible. So obviously the ball was first going up, and then there was a point when the velocity became zero in the magnitude, and later it changed its direction, it became negative, and the velocity is even increasing in the negative side. So because velocity is a vector, we have to choose the direction, we have to give signs to them. So let us say if the body is moving up, I have considered it positive, and if the body is moving down, I take the sign of the velocity as negative. So at this point, we can see the velocity is in upward direction, and here the velocity is in downward direction, so it becomes negative. So perfectly it satisfies the conditions of oblique projectile motion. So it means that these two graphs are pertaining to, let us read the options. These graphs could represent the motion of an object fired from a cliff vertically upwards. No, because it does not have horizontal velocity. At an angle above the horizontal? Absolutely yes, because this is what is oblique projectile. Horizontally? Not at all, because it will be horizontal projectile, and we know that in this case, the velocity is not changing direction. Either it is zero or it is negative. Now at an angle below the horizontal? No, not at all. So our answer is B. Let us verify it from the IB mark scheme. Exactly, the answer is B. So if there is any other doubt, please do let me know. All the best. Bye.